In this video, we will unravel application with respect to light wave, and we have all this to discuss.
Good day, viewers. Welcome back to this channel, to this page. Now, in this concept, we want to unravel the aspect that has to do with light wave and popular questions that do come out on this aspect. The aspect that has to do with rotation of mirror, reflection, inclined plane, and the likes. Now, meanwhile, I'm going to start with the first aspect, which is the aspect that has to do with rotation of mirror. And we have the first question there. And what does the question says? The question says a mirror. Okay, sorry, a ray of light strikes a plane mirror at an angle of incident 35 degrees. If the mirror is rotated through 10 degrees, full stop, through what angle is the ray rotated? Okay, through what angle is the reflected ray rotated precisely? The question says a ray of light strikes a plane mirror at an angle of incident 35 degree. If the mirror is rotated through 10 degree, through what angle is the reflected ray rotated? Now, the answer to this question is 20. But meanwhile, don't let me rush to the answer. Basically, this actually interprets the question. Now you have the ray of light, which is incident at 35 degrees. Okay, we're going to have the reflected angle too, reflected ray. Now this is the normal. Now this is the incident ray. This is the reflected ray. Now this is the incident angle, which is 35 degrees. All right. Now we were asked to, the question says, if the mirror is rotated through 10 degree. Okay, now this mirror is actually rotated through 10 degree. We assume this is the rotation through 10 degrees. Okay, now in that wise, we have the diagram in this pattern. This is the incident, then this is the reflected. Now we are asked, they said, through what angle is the reflected ray rotated? Now the reflected ray is going to be rotated using the equation 2 theta. Now 2 theta is the same thing as 2 multiplied by the 10 degrees, which is 20 degrees. All right, so that is the answer to that. Now you have no business, you have no any issues with the incident ray, the incident angle, which is 35 degrees Celsius. Okay, so that is a condition. A ray of light can be made to rotated through the reflected, through the normal and the reflected, and also through the incident and the reflected ray. Okay, so this is just one aspect of that concept. Now, in the second question, we have another question. And what does it say? The question says, it has a diagram. It said in the diagram, in the figure below. In the figure below. And where is the figure? Here is the figure. All right. In the figure below, an incident ray XY, an incident ray XY makes an angle of 70 degrees with a fixed line AY. which is normal to the surface of the plane mirror. Alright, if the mirror is turned as indicated by arrow through 42 degrees, alright, what angle will the reflected ray make with AY? Now let's get the question clearly. Said in the figure below, an incident ray AY, this is the incident ray, sorry, an incident ray XY rather, this is X, this is Y, okay, makes an angle of 17 degrees. It makes an angle of 17 degrees with a fixed line, okay, AY. This is a fixed line, which is the normal AY, which is normal to the surface of the mirror. Now, if the mirror is turned as indicated, okay, by an arrow, if the mirror is turned as indicated by an arrow through 42 degrees, what angle will the reflected ray make with AY? Now, so the angle of solution to that, so the angle is going to make with the normal is the angle between the reflected ray, angle between the reflected ray and the normal. Now, when you are asked to calculate the angle between the reflected ray and the normal, you use the incident ray plus 2 theta to get the angle between the reflected ray and the normal. Now, we said earlier in the first question that if it is just the angle of the reflected ray, you use 2 theta. Now, in this case, the angle between the reflected ray and the normal, you're using this. Now, from the question, the incidence ray is 17 degrees and the rotated angle with the fixed point is given to be 42 degrees. All right, from the question, 42 degrees. So therefore, you have the 17 degrees plus 2 multiplied by 42, all right, degree. So that will be 17 plus, that is 84. So 17 plus 84 is 101 degrees. That is the answer with respect to that. Now, so those are the first question with respect that has to do with rotation of mirror. Now, in another aspect, we have the aspect that has to do with inclined plane. Inclined plane. And the question reads, and what's the question? The question says, an object placed, an object placed in front of 2 plane mirrors inclined at an angle theta, if the total number of images formed is 7, find the value of theta. Okay, we are asked to find the value of theta. Now, how do we solve that question? Now, for this kind of question which has to do with inclined plane, Now we know that number of images is equal to 360 divided by theta minus 1. So now this is the angle made. This is the number of images formed. So we say the number of images has been given in the question to be 7. Alright, we're looking for this theta. Now, so 7 is equal to 360 divides theta minus 1. Okay, so when minus 1 come to this side, it's going to change to plus. So we have that 7 plus 1 is equal to 360 divided by theta. So that is 8 equal to 360 divides theta. So 8 theta will be equal to 360. Then you divide both sides by 8. So theta will therefore be equal to, when we divide this by 4, we have 2. We have 90, then 45 degrees. So we seek you and encourage you to subscribe to this our channel so you can get more and more of this question. Alright, so now we quickly move to the next question. And what do we have? What does the question says? Now, in this question, we have that an object is placed in front of 2 mirrors inclined at an angle, inclined at 90 degrees. How many images will be formed? Okay, how many images will be formed? Now, solution to that problem, solution to the question. The question asks to calculate the number of images that will be formed. We have been given the angle to be 90 degrees, right? So they said the number of images. Now, using the equation, the number of images equal to 360 divided by theta minus 1. So which means 360 divided by 90 minus 1. Okay, so when we cut, you have 4 minus 1. So the number of images formed there with respect to the question is 3. Okay, so that justifies that. Now we move to another aspect of light energy, so which is angle of deviation, in case we've been asked to calculate angle of deviation. All right, so now we have a question here, very essential and important one. Said an engineer intends to deviate a light ray from its path by 110 degrees through reflection from a plane mirror. All right, so we've been asked to calculate the angle of incidence. We are asked to calculate the angle of incidence. Now, like I said earlier, it is quite very important you kindly subscribe to this channel so you can get as many as possible solutions, and at the same time you can also seek for online classes, so we teach you efficiently and effectively. So this will really help you a lot. Now, solution to this question: how do we unravel question of this nature? Said an engineer intends to deviate a light ray from its path by 110 degrees through reflection from a plane mirror. Calculate the angle of incidence. Okay, now the angle of deviation has been given. The angle of deviation has been given to be 110 from the question. An engineer intends to deviate a light ray from its path by. So now the deviation angle is 110 degrees Celsius. All right, through reflection from a plane mirror. So we asked to calculate the incidence angle, the angle of incidence. Now we've learned that angle of deviation is twice the glancing angle, but glancing angle is equal to 90 degrees minus the incidence angle. So we're going to substitute this, okay, in this equation. We substitute the G, which is equal to 90 degrees minus I, in this equation. So we have that the angle of deviation is equal to 2 into the bracket of 90 minus the incidence angle. Now the question requires us to calculate the incidence angle. Now the angle of deviation has been given to be 110 degrees, equal to, then we can easily remove this bracket. 2 multiplied by 90, that is 180 degrees minus I. All right, so now we bring this 180 here, so we have that 110 degree minus 180 degree equals to 2I. Apologies please, this should be 2I when we remove the bracket. All right, so that's 110 degree, sorry, minus 2I, apologies, minus 2I. All right, so now that will be 70 degree minus 70 degree. When you subtract this and this from that, rather, then you are equal to minus 2 degree. So this can easily cancel out this. Then 2 divide 70 degree, you have your incidence angle to be 35 degrees as the answer. Apologies there. Now again, quick one. The question says an engineer intends to deviate a ray of light through its path by 110 degrees through a reflection from a plane mirror. Calculate the angle of incidence. Now to calculate the angle of incidence, we know that the angle of deviation is twice the glazing angle, but glazing angle is equal to 90 degree minus the incidence angle. Then therefore the angle of deviation is equal to, you substitute this in this, so you have 2 into bracket 90 minus I. So you remove the bracket, 110 is equal to 180 minus 2I. So you collect like terms, then you calculate and you get your incidence angle. Okay, so I think that has been justified. Now we have another question that has to do with angle of deviation. Okay, the question has to do with the diagram below, and here you have the diagram. Now what does the question says? The question says two mirrors of the same length are arranged, okay, as shown below. As you can see here, these are the mirrors arranged of the same length, okay, are arranged as shown below. So a ray of light XP, this is SP, okay, a ray of light SP strikes the system at P. A ray of light SP strike the mirror, okay, which is the system at P, okay, and emerges along QR. Then emerge here, a strike here, and then emerge QR, emerges here, okay. Now the question continues. The emergent ray has been deviated through, okay, the emergent ray has been deviated through what angle? Now here we have to be very careful to get the total emergent ray. Now the glancing angle here is 50 as given, so we have to get the angle of incidence. Now we draw out the normal, okay. On drawing out the normal, to get the angle of incidence, we subtract the glancing angle is equal to 90 degree minus the incident. So we need to get the incident angle. So the glancing angle is 50. So the angle of incidence here will be 40 degree. So the reflected angle to this mirror is also 40 degree. All right. Then glancing angle here will be 50 degree. Now for the second mirror, it has its own number too, alternate angle. So this will be actually the incidence angle, okay, for this second mirror, okay. Then the reflected angle is going to be 50 as well, according to the first law of reflection. Why the glancing angle, alternate angle here will be 40. The glancing angle here will also be 40 degrees. Now we are asked to find the emergence ray that has been deviated. Now for this first mirror, I call this M1 for the first mirror, I call this M2 for the second mirror. Now the angle of deviation will learn to be equal to 2G, that is twice the glancing angle. Now you now say for M1, for the first mirror, you calculate the angle of deviation, which is D is equal to 2 multiplied by the glancing angle here is 50 multiplied by 50 degrees, which is equal to 100 degree, okay. For that's the angle of deviation for the first mirror. Now for M2, using the same formula, angle of deviation twice the glancing angle. So that's going to be M2 will be equal to 2 multiplied by the glancing angle here is 40. All right, the glancing angle here is 40 degree. So 2 multiplied by 40 degrees, which is equal to 80 degrees. Now to calculate the emergent ray that has been deviated, so you have to add the two, okay, deviations from the two mirrors. So the total emergent ray, will be equal to 100 plus 80 degrees. So which is equal to 180 degrees. Okay, and that is the answer to that channel. So I will not stop saying this. You have to assist in subscribing. Just click on the subscribe button. Kindly subscribe to this channel so we can help you. We can actually give you everything very easy for you. And at the same time, you can also subscribe, to our online classes, which will really assist so much. All right. So, think we still have do we still have question? Yeah, we have question. We have another question in another aspect of light wave, which is the question that has to do with law of reflection, though we've been dealing with the law of reflections in the previous questions too. Now, and what does this question says? The question says a ray of light, all right, a ray of light makes an angle of 35 degrees with a plane mirror. All right, what is the angle of reflection? What is the angle of reflection? So how do we solve that? Now let's use a simple diagram to explain this better for easy understanding by our viewers. Now they said a ray of light incidents at an angle, a ray of light makes an angle of 35 degrees with a plane mirror. Okay, so which means the incidence angle we don't know yet. It makes an angle of 35 degrees with a plane mirror. So now this is 35 degrees. That is not the incidence angle, but rather that is the glazing angle when you check it. So a ray of light makes an angle of 35 degrees with a plane mirror. All right, so which means the incidence angle really would therefore be 35 minus 90. Okay, so that will be 45. Okay, sorry for that break, please. So now this is actually the glassing angle. Now to get the angle of incident really, so that will be 90 minus 35, which is 55 degrees. Okay, that is the incident angle. Then the question asks to calculate the angle of reflection. Now according to Snell's law, or the law of reflection, so which is the incident angle is always equal to the reflected angle. So the reflected angle is going to be 55 degrees. Okay, so angle of reflection or reflected angle is equal to 55 degrees. Okay, so you are given the glancing angle, so you take away 90 from the glancing angle, 90 degree minus glancing angle. Okay, so you get the incidence ray, that is 90 minus 35. So the incidence ray is 55 degrees because the incident angle is equal to reflected angle. So reflected angle is 55 degrees. All right, so finally we have another question here that has to do with this diagram. And what does the question says? Question says two mirrors are inclined as shown in the diagram. Okay, a ray AB strikes the first mirror at B. A ray AB strikes the first mirror. This is the first mirror at B and emerges from the second mirror. Okay, it strikes the mirror at B and emerges from the second mirror along CD. Along CD. Now the angle of reflection at the angle of reflection, all right, at the second mirror is what? So what is the angle of reflection at the second mirror? So this first mirror is M1, let's denote that, and this second mirror is M2. Okay, so the question says, and I read again for clarity, two plane mirrors are inclined at angle 90 as shown in the, so these two mirrors are inclined at 90, this angle here means 90 degree as shown in the diagram. A ray AB strike, so this should be written once, strikes the first mirror at B. A ray AB strikes the first mirror at B, okay, and emerges from the second mirror, all right, strike from here and emerges from here along CD. The angle of reflection at the second mirror is what? Okay, now like we've been doing, or like we've solved above, this here is the glancing angle G, 35 degree. So we need to calculate the angle of incidence. So the angle of incidence, this place is the angle of incidence. So you take away 90 from this, and that is 55 degree. Okay, so this reflected angle too will also be 55 degree. Okay, then leaving this place to be 35. The logic is when you add everything here together, you should get 180, because angle on a straight line is 180. Now, since this is the angle of incidence, then the angle of reflection here will be 55 as well. Now, then it strikes the second mirror. Okay, now we also have normal, alternate angle. If this is 55, then this place, the glancing angle here will now become, 55 degree, such as the incidence ray for this second mirror M2 will be 35, and its reflected angle will also be 35, making this glazing place be 55. Okay, so now the question says the angle of reflection, okay, at the second mirror is what? The angle of reflection at the second mirror. So from this diagram, what will be the angle of reflection? The angle of reflection here is 35 degrees. Okay, 35 degrees. So that is quite simple and logical. So you can look that again. The ray of light strikes. Okay, the glancing angle is 35 degree. Therefore the incidence ray will be 55. The reflected ray is 55 here. Okay, now the reflected ray become the incident ray on this second mirror. So now on coming down here, it will now become the glancing for this second mirror, so that the incident ray for this mirror will therefore become 35. Okay, so the reflected ray is 35 and the glancing will be 55. So now the answer to that question is 35 degrees. Okay, so I will quickly want you to tell me the answer to this question when you have two mirrors as well inclined at angle of 90. Okay, you send your answer to the comment section. So you have the incidence ray then strikes this side, then emerges here. So if this is A, B, and this is C, then D, it actually incidents here. Okay, so I call this mirror 1 and this mirror 2. Now if the ray of light, okay, good. Now, and you are given the glazing angle here to be 30 degrees. Okay, so I want you to tell me what will be the angle of reflection from the second mirror, M2. Okay, so do that and send your answer to the comment section. So recharge card of very good amount will be given to the correct answer. Okay, so like I do say, try as much as possible to subscribe to our YouTube channel to get more of the videos. All right, do